In this part, we're told the two balls collide elastically, and we're asked to find the velocity of each ball just after the collision. The main ideas needed to solve this problem are knowing what an elastic collision is and being able to do the algebra to prove the answer that we'll get. In an elastic collision, momentum is conserved. We can write this in equation form as the mass of ball A times the velocity of ball A just before the collision, which we just found in part A, is equal to the mass of ball A times the velocity of ball A after the collision plus the mass of ball B times the velocity of ball B after the collision. Kinetic energy is also constant in an elastic collision. Mathematically, we can write this as the kinetic energy of ball A before the collision is equal to the kinetic energy of ball A after the collision plus the kinetic energy of ball B after the collision. Because the mass of ball A is equal to the mass of ball B, we can make some simplifications to the equations we just wrote down. Conservation of momentum now becomes the velocity of ball A pre-collision is equal to the velocity of ball A post-collision plus the velocity of ball B post-collision, and the fact that kinetic energy has to be conserved becomes the velocity of ball A squared pre-collision plus the velocity of ball A after the collision squared plus the velocity of ball B after the collision squared. We can now use these two equations to solve for VA prime and VB prime. We take equation 1 and solve it for VA prime, and then square both sides to find this expression here. We then substitute in this whole expression for VA prime squared in equation 2 to find this equation here. The equation we just found simplifies to the point where we see that VB prime, the velocity of ball B after the collision, is equal to VA, the velocity of ball A just before the collision happened, which we found in part A to be 1.87 meters per second. Substituting in this result into our equation for VA prime, we see that the velocity of ball A after the collision is equal to 0. So what happens is initially ball A comes in with a velocity VA and ball B is at rest. Then after the collision, ball A is at rest, and now ball B continues on with that same velocity that ball A had initially.